So that's the end of that lesson on vector spaces and things like that. Now let's discuss web crawling and preparing documents. So you can write a web crawler in an introductory computer science class, and probably lots of classes have set this, and lots of crawlers have crawled around based on this. So you start with a list of URLs you visited already. It could be empty, and you would have at least one URL to start with. And then you fetch the URL off the list, check if it's done. If it's not done, you go off to the web and collect it. You bring it back, you hand the document to a document analyzer. The document analyzer goes and does all sorts of nifty things with the terms in the document, but among other things, it extracts all the URLs in the document and adds it to the list of new URLs to visit. And then you proceed ad infinitum until you've crawled the whole web. As we know, there are isolated sets of the web, and so you do need to seed it properly to get all URLs this way. And there are also all sorts of subtleties, encrypted pages demanding you be polite and not load the server down by fetching lots of information from it. There are pages which are dynamic, and there's the so-called deep web, which are effectively databases with a web front end and things like that. So all of that make it more complicated, but that's engineering. I don't think there's much point in principle there. So then we have these. So we fetched it from the web. What do we do with it? Well, you're going to have to get these terms, which are these canonical words of the English language. So you first take the HTML document, which actually could be Word, it could be PDF, as well as, of course, HTML in various flavors, and it's got to be converted to a text document. Once you've done that, you run it through a PDF to text converter, for example, or a Word to text converter. Then you do so-called tokenization. You view it as a string of words, and you remove the formatting and the punctuation and the capitals. Even if their capitals are important logically, they're not so important for query matching because people don't use capitals very often in queries. You convert common forms, like you use USA, not U.S.A. You drop accents, as in naive, and then you have canonical tokens, which your document has become. Then you have you may or may not remove stop words like ears, a, to, the, for. One reason to keep stop words is that some phrases have to have stop words, like to be or not to be is full of stop words. You won't, if you've removed stop words, you'll never be able to respond to the query to be or not to be, whereas it's actually likely to be a perfectly reasonable thing to respond to if you happen to know that you have twice and it's had a certain location such that to is followed by be is followed by or is followed by not, and so on. So to be or not to be is a relatively easy phrase to find, and doesn't require too much changes to your search engine to find it. Then we have stemming and normalization, so we convert things like singing and sung to sing, and better to good, and best to good, and cope with non-trivial synonyms such as automobiles and car, not and are not and aren't, and different date formats, and then you end up with terms for your lexicon. So those terms are the things that are in your bag of words, which are really bag of terms. And those terms are the things that define each dimension of the vector space model. Here's another slight subtlety, which we certainly want to do for, say, Google Scholar, where we want to actually identify especially the citations, and especially the abstract, and especially the authors, and especially the title. So that comes from a segmentation algorithm, which chops the document up into parts. And CiteSeer, of course, probably pioneered this. Well, this is one of the early analyses of scholarly works. So that's important. If you want to do the many documents, many information retrieval systems like those looking for figures in a document and things like that, they need to do this segmentation. So that's the end of that short discussion of actually how we crawl the web and convert it into canonical form. Now we have a little discussion of indices, which will be the next lesson.